Hi, in this video I'm discussing the Unit 2 IAL paper May 2020, right? So the first question says waves can be represented on graphs of displacement against distance and displacement against time. Which of the following properties can only be determined by combining information from both graphs? Right? You should download the paper somewhere. Right. So the first answer given amplitude, the second one is frequency, third one is speed, and fourth answer amplitude. Sorry, wavelength. Right. So when we consider the two graphs, displacement distance graph. So from the displacement distance graph, I use X for displacement. So if I use displacement distance graph, the graph will be something like this. We can get the wavelength. So one full oscillation. So this will be the wavelength, right? So by using displacement distance graph, we can find the wavelength. By using displacement time graph, we can find the period of the wave. So this is one full oscillation. The time taken for one full oscillation, that will be period, right? So we can find the period, and by using F equal 1 over T, we can find the frequency from displacement time graph. But the question is about, by using both information given in displacement distance graph and displacement time graph, which quantity can be found. So we know the wavelength and frequency. By using V equal F lambda, we can find the speed. So one of the answer given is speed, that is answer C. So the first question, the correct answer is C, speed. Okay, question number 2 says two waves from the same source arrive at a point with path difference 3 lambda by 8, where lambda is the wavelength. Which of the following is the phase difference of the waves at this point? So there are four answers given: 34 degree, 68 degree, 135 degree, and 270 degree. We'll find it. So we know the equation phase difference equal. I can use the notation for phase difference equal 2 pi over lambda times path difference. Phase difference equal 2 pi over lambda times path difference, right? So the path difference is given as 3 lambda by 8. So substitute here 3 lambda by 8. So you will get, the answer will be, you will get 3 pi by 4. 3 pi by 4 in radians. So only thing you need to convert this to degree. You know pi is equal to 180 degree. So substitute here 3 into 180 divided by 4. So you will get answer 135 degree. That is the phase difference correspond to path difference of 3 lambda by 8. So that answer is given. The answer C, question number 2. The correct answer is C. Okay, so this is the diagram for third question. It's about diffraction grating. The diagram is given in the question paper. So there's a diffraction grating. There are 300 lines per millimeter. So in 1 millimeter, there are 300 lines. So D will be number of lines per millimeter. So that will be 1 over 300 number of lines per millimeter. So I can say per millimeter. So the question is, which of the following calculations should be used to determine the wavelength in millimeter? So I don't need to convert it to meter. So we know the equation d sine theta equal n lambda. The question says at 0.40 meter from the central maximum, they observe the first order diffraction. This is the zeroth order. This is the first order is obtained at 0.40, so n equal 1, right? So I need to find the angle theta, right? So here I can find the angle theta by using tan theta is equal to opposite 0.40 over 2.00. So theta is going to be tan inverse 0.40 over 2.00. That's the angle theta. And we know the equation d sine theta equal n lambda. We need to find the lambda. So d is this one. So in millimeters, so I can substitute 1 over 300 times sine theta equal n is equal to 1 into lambda. So lambda is going to be sine theta over 300, where theta is equal to tan inverse 0.40 over 2.00. So this answer is given in the MCQ as the answer D. So the question is about the wavelength. So answer D, question number 3. The correct answer is D. Okay, question 4 is very simple. It's about base quantity, derived quantity. They are saying which of the following statements about physical quantities or unit is correct. First statement says current is a derived quantity. You know current is a base quantity, so it's a wrong statement. Answer B says power is a derived quantity. Yes, it's a correct answer. Anyway, we'll check the other one also. The answer C says coulomb is a base unit. Actually, coulomb is a derived unit. And the last one says the volt is a base unit, volt is a derived unit. So the correct answer is B, question number 4. Correct answer is B. Okay, question number 5 about ultrasound scanning. The question is ultrasound has number of different uses in medicine. Which of the following is the main reason why ultrasound is not used to perform scans of the chest and lungs? Okay, so first answer says they are in the lungs causes most of the ultrasound to be reflected back. Yeah, you know, the amount of reflection depends on the densities, actually acoustic impedance, we call the ratio of the acoustic impedance, or we can say it depends on the difference in the density. So if the difference of the densities at the boundary is big different, it's very large, then there will be large amount of reflection will happen, so less amount of ultrasound will penetrate further inside. So there will be reflection at the first boundary of lungs air, right? So we are using ultrasound from here. This is air. So there will be large amount of reflection might occur at the first boundary. So the less amount will penetrate into the through the air to the other boundary. So we won't be able to scan the ultrasound by scan the lungs by using ultrasound because of the air. The density ratio will be the boundary. It means of flesh or muscles, whatever it is, the lungs. This is air, so there will be larger difference in the density that will cause large amount of reflection at the first boundary. So answer A, you can't use ultrasound to scan lungs. Okay, question number 6 says about which electrical component has the current potential difference graph shown. So they are giving a graph something like this. This is the graph given, question number 6. This is current and this is the potential difference. Anyway, you can see that the graph is turning towards the current axis. That means when the voltage increases, current is increasing and resistance is decreasing, because graph is turning towards the current axis means the resistance is decreasing. So when the voltage increases, we know current increase, the temperature or the heat produced will increase. That causes the resistance to drop. So which type of materials they have? They are the negative temperature coefficient materials, semiconductors. So answer is D. D is thermistor. We know thermistor is made of semiconductor. So question number 6, answer D. Okay, question number 8. A small metal tube with sides of length x is connected in a circuit. The current through the tube between opposite faces is I. So there's a metal tube. So if I consider this as a tube, so each side is length x, this also x. So current is entering to this side, right? That is current I. So we know that the resistance R equal rho L over A. A means the area which is in right angle to the direction of current flow. So here A will be x squared and length is, the current is going to flow along this length, is it? Current is going to come out from here. So the length is x. So rho R is equal to rho times L, I can say x over x squared. So R will be rho over x. The question is, The voltage applied across the opposite ends is equal to V and the current flow is I, they are saying. So we know that R equal V over I. The question, which expression gives the resistivity? Make the rho subject. Rho is equal to Vx over I. So Vx over I is answer A. Okay, answer A. Question number 7. Okay, question number 8. Which of the following statements about waves is correct, right? So there are 4 statements given. Both longitudinal and transverse waves can be polarized. Is a wrong statement. You can't polarize longitudinal wave because for a particular direction of wave motion, the oscillation should be parallel to the direction of wave motion, and that is the only possible direction of oscillation. So there can't be any other possible direction of oscillation in longitudinal wave. That means we say longitudinal cannot be polarized. So answer A is a wrong statement. Answer B, neither longitudinal nor transverse waves can be polarized is a wrong statement. We can polarize transverse wave. Only longitudinal wave can be polarized is the answer C. So longitudinal wave cannot be polarized. So the correct answer 8 is D. Only transverse waves can be polarized. So correct answer 8 is D. Okay, question 9. Two copper wires are placed in series in a complete circuit. So maybe two different pieces of copper wires are connected in series. Maybe this is the current circuit, maybe this is the first wire, and maybe this is the second wire. They are connected in series. So they will have the same current, copper wires, both are copper. So they will have the same resistivity, both have the same current, right? At the same time, they'll have the same charge carrier density also. The question is, which of the following must be different for the two wires? So they are saying in both wires, the electrons in two wires have different values of drift velocity. So they have different drift velocities. So, which statement is correct? So, what can be the different? Which quantity can be different in two wires? So, if you think about I equal NAEV, both wires have same current because they are connected in series. Both wires are made of copper, so they will have the same charge carrier density. E is the charge of an electron, that will be same for anything. All electrons have the same charge. So, since the drift velocity differs, area of cross section, they should have different area of cross section. So, question number 9, answer B. They have different area of cross section. Okay, question number 10. This circuit diagram is given and they are saying the potential divider including a battery of negligible internal resistance and a light dependent resistor, this is LDR. The potential difference across fixed resistor is measured by using voltmeter. There are 4 statements given. Which of the following statements about this circuit is correct? First one, if the resistance of the LDR halves, the voltmeter reading half. No, because if the resistance of the LDR becomes half, current flow will increase because total resistance will decrease. Is it? When you reduce the resistance of LDR, the total resistance will decrease. When the total resistance decreases, current flow will increase. When the current flow increases, voltmeter reading should increase. But they are saying voltmeter reading becomes half. So answer A wrong, right? Second statement, the statement B, statement A is wrong. Now statement B, increasing the light intensity would decrease the voltmeter reading. When you increase the intensity of light, resistance will decrease. When the resistance decreases again, current flow will increase because total resistance of the circuit is decreasing. Current flow will increase. When the current flow increases, voltmeter reading should increase, but they are saying voltmeter reading will decrease. So statement B also not correct. Statement C, increasing the light intensity would have no effect on the voltmeter reading. No, it's a wrong statement because I already explained what will be the effect when the intensity is increased. Answer D, the voltmeter reading added to the potential, the voltmeter reading added to the potential difference across the LDR. That means the voltmeter reading, if I say V1, that is the voltage across the resistor. If voltmeter is reading the voltage across the resistor, if you add that reading, that is V1 plus V2, that will be equal to 12 volt. They are saying, yes, it's a correct statement, because in this closed circuit, if you think about the Kirchhoff's second law, the sum of the voltage across the components will be equal to EMF. So answer D is the correct one. Okay, question number 11. This diagram is given. So there's a glass kept inside a container. So there is water, outside is air. The block of glass is submerged in a container of water. A ray of light traveling in the water is directed towards the glass. So this is the light ray that makes angle theta with the normal to the boundary of water glass. And the refractive indexes are given. So you know that the refractive index equals speed of light in vacuum divided by the speed of light in the medium means the glass has larger refractive index means the speed is less. So glass is optically more denser medium compared to water, because refractive index is more means speed is less. Speed less means it's optically more denser medium. So the first part, the A part, calculate the angle of refraction within the glass block. If the theta is 43 degrees, so they are giving the theta as 43 degree. The question is find the angle. So we know that glass is optically more denser medium means when it light enters from air to glass, it will move towards the normal, is it? So I can say that angle R, angle of refraction. So I can say I can use the equation, the general equation, n1 sine theta 1, so 8 part I am doing, n1 sine theta 1 equal n2 sine theta 2. So that means light is traveling from water to glass, nw sine theta equal ng sine r. So nw 1.33, sine theta is given in this question 43 degree. So they are giving it theta equal 43. So sine 43 equal nw is 1.33. So this is ng 1.52 sine r. Solve it and find the r. The answer will be 36.6 degree. Second part, determine the critical angle. So B part, determine the critical angle for this glass water boundary. It won't be water glass, because you know the critical angle occurs when light travels from optically more denser medium to optically less denser medium. So when light travels from glass to water, there will be critical angle inside glass. Okay, so they ask you to find the critical angle. So there I can change this diagram slightly. So I can redraw this diagram like this. So this is the boundary, this is glass. So they're asking to find the critical angle for glass water boundary. So if I say this is the normal to the boundary, and at critical angle, what happens? The light is entering at critical angle from glass. So if I say this is C, the light will travel along the boundary. So this will be 90 degree inside water. So same equation I can use for B part. I can say the same equation. That means here Ng sine C equal Nw sine 90. So Ng I know that 1.52, sine C equal 1.33, sine 91. Find the C. Find the C. You will get 61 degree. That's the answer for part B. Okay, question 12. This diagram is given on page number 9, May 2020 IAL Unit 2 paper. So their first part, that is A part, calculate a value for the voltmeter reading. Remember that voltmeter reads the voltage applied across its terminals. Okay, voltmeter reads the voltage applied across its terminals. So voltmeter is connected across 55 kilo ohms. So voltmeter will read the voltage across 55 kilo ohms. So I can use potential divider method, because normally we assume there is no current flow through the voltmeter and the internal resistance of the voltmeter is very large. So even when the voltmeter is connected across, that is parallel to 55 kilo ohm, the overall resistance will not change. Say for example, if I say the internal resistance of the voltmeter is RV, so the overall resistance of this combination after I connect the voltmeter, if I say the internal resistance is RV, which is very large, if I say 1 over R naught equal 1 over 55 kilo ohm plus 1 over RV. That's going to be the equivalent resistance of 55 kilo ohm and the internal resistance of the voltmeter. Because if RV is very large, what will be the equivalent resistance of combination of these two? If RV is very large, 1 over RV will be almost 0. So 1 over RV almost 0 means 1 over R naught. The equivalent resistance is going to be 1 over 55. So R naught is going to be 55 kilo ohms. That means if the resistance of the voltmeter is very large, even after I connect the voltmeter across the component, there is no significant change in the resistance, right? So I can take here the internal resistance of the voltmeter is very large. Okay, so they asked to find the voltmeter reading means, so voltmeter is going to read the voltage across 55 kilo ohm, and this total applied voltage will be divided across them according to the ratio of their resistance. So I can say a part voltmeter reading is going to be the voltage across 55 kilo ohms. So I can use that is voltage across 55 kilo ohms. So I'm going to use potential divider method. So the reading will be, the voltmeter reading will be total applied voltage 1.5 into the resistance 55. I'll keep it in kilo ohm because both are in kilo ohms. Total resistance 12 plus 55. So the answer will be 1.23 volt. That's the reading of the voltmeter. Right, B part is something explaining type question. They're asking, the student sets up the circuit and observes that the reading on the voltmeter is lower than the value calculated in A. So this is the calculated value, but practically he observed the reading is lower than this one. Explain two reasons. Careful, they are not saying state two reasons. Explain. So whatever the reason you are telling, you should just explain it briefly, right? Explain two reasons for the lower voltmeter reading. So first reason I can say the first reason, maybe the cell or the power supply might have internal resistance. So the voltage across both 12 kilo ohm and 55 kilo ohm is going to be the terminal voltage. If it has resistance inside, if it has internal resistance, so the voltage that supplied by the cell is going to be the terminal voltage, which is given by V equal E minus IR. So that will be smaller than 1.5 because a certain amount of voltage is dropping inside the cell due to the internal resistance. So the voltage what I used here 1.5, but I should use a value smaller than 1.5 if it has internal resistance. That's first reason you can say. You are getting 2 marks for that. One is the reason, then explanation. Second reason I can say, maybe the connecting wires might have resistance. So if the connecting wires have resistance, they all are in series with 12 kilo ohm and 55 kilo ohm. So there will be voltage drop on the wires. So when there is voltage drop on the wires, so they are going to get only the remaining voltage. So it won't be 1.5, less than 1.5 you can say. Third one, I can say the internal resistance of the voltmeter is not large. It should be very high, is it? Ideal voltmeter means it should be very high. But if it has reasonably lower internal resistance, then this total resistance, the combination is going to be lower than 55. It's going to be lower than 55. You know, when you are connecting components in parallel, the equivalent resistance become lower than the resistance of the combination, resistance of the components, those are connected in parallel. So if it has lower resistance, not very high, so the total resistance of this combination will be smaller than 55. So here I should not use 55, I would have used a value smaller than 55, then the reading will be lower. That also you can say. So there are three reasons, any two reasons with explanation. Okay. Okay, so question number 13, displacement distance graph is given, and the question says an active noise reduction ANR is a system used to reduce unwanted noise, something like a noise cancelling, some not exactly the same, but something like noise cancelling headphones. The function is the same almost. In ANR, a second wave or sound wave is produced that cancels the first. ANR is used in aircraft to reduce the noise heard from the engine. So, you know, if you want to cancel two noise, you know, they should overlap. They should have the same frequency. That means they should be coherent waves. They should have same frequency, same amplitude, and they should overlap antiphase. Okay, these are the three conditions if they want to cancel each other. They should be coherent and overlap antiphase. So coherent means they should have the same frequency and the amplitude should be almost same and should be exactly same if you want to completely cancel each other. They should overlap antiphase. So this is the graph or displacement distance graph on the particular flight. The noise from the engine has a frequency of 0.85 kilohertz. The graph shows a possible second wave. So this is the second wave, means the wave generated in ANR is given by this graph, and they are saying the frequency of the engine is 0.85 kilohertz. This is the second wave generated rather compared to the noise from the engine. This is the second sound generated from the ANR, and the speed of sound in air is given 340 meters per second. The question is, determine whether this wave could be suitable to cancel the noise from the engine. Okay, so only thing we can find out, they should overlap antiphase, that we can't show from here, but only thing, they should be coherent, is it? So that means they should have the same frequency, right? So we'll find the frequency by using this graph. This is a displacement distance graph. So we know the wavelength from crest to crest, 0.5 minus 0.1. So the wavelength is going to be 0.4 meter. We'll use V equal F lambda for this sound. So speed is given 340 meter per second in air. Only thing we need to find the frequency. Lambda is 0.4. So you will get frequency will be equal to 850 hertz. When you convert to kilohertz, because we need to compare with the frequency of the sound generated by the engine, so that will be 0.85 kilohertz. So this frequency is suitable. Only thing, they should overlap antiphase. So that is a question in part B. Okay, so B part of question number 13, this diagram is given. So this is a passenger, it's a top view. If you see from the top, right? If you see from the top, so he's receiving two different sounds from engine. It's coming from front side, and ANR sound from the ANR. To cancel this sound, it's sent from left side of the passenger. Now the question is, for a particular passenger in an aircraft, the noise from the engine travels as wave towards the passenger from the front side. An ANR system creates a second sound wave that is directed towards the passenger from the side. Okay, so that's given on the diagram. Explain how this can lead to the sound being cancelled for one ear but louder for the other ears. Careful. But there is actually, we can't 100% assure the sound will be cancelled, right? But the question is, if sound is cancelled for one ear, the other ear, the next one, will hear louder sound. So the question is better, you have to think now. There's no it's not compulsory to cancel the sound, but in case if he is not hearing sound by one ear, then the next one can hear a louder sound. How is it possible? Now look at here. So if they want to cancel each other, we learned that they should overlap antiphase, right? So when you think about this sound, anyway, this sound is going to diffract around his head, right? So this sound could diffract around his head and he can get the sound on both ear, right? But this sound also going to diffract around his head. So this ear will get the sound directly, the left ear. The right ear is going to get the diffracted sound from a nerve system. So that sound will be diffract around his head and can reach the second ear. Now the problem is, if you get cancelled, if the sound is cancelled here, that means the path difference. So that means we don't consider curved say. You can think about double slit experiments in double slit, right? So the sound waves are diffracting like this, is it? So waves are diffracting, even light or sound, whatever it is. If you want to find what will happen at this point, even though these diffracted waves are going to overlap here, but we consider the path difference by considering the straight line, is it? We consider these 2 points when they overlap at this point. If I say the distance, this one d2, this one d1, so what will happen here depends on the path difference d2 minus d1. So here also we don't consider this curved path, we consider the path difference. Say imagine the sound is coming from somewhere source here. So if I think about left here, that means this distance, if I say d1, and this distance, I'll remove this thing, but I wrote here this distance d2, right? So at this left ear, the two sounds, if they form destructive superposition, d2 minus d1 forms destructive superposition, right? But when you consider the right ear, the path, this one will be same as this one. So this also will be same d1. But this is here, when you consider the right ear, the sound has to travel additional distance that is equal to the size of the head or the diameter of the head. So if this diameter of the head is almost equal to 20 centimeter, but it's not compulsory, everyone won't have the same size of head, but in case if that is equal to 20 centimeter, that means that is half of the wavelength of the sound. We found in the previous part the lambda is equal to 0.4 meter. We found it in the previous part, is it? That is part A. From the graph we found it, the lambda is equal to 0.4 meter. So if it is 0.2 meter or 20 centimeter means 0.2 meter. So if the size of the head is 0.2 meter, now what's going to happen? At this point that is happening destructive superposition. So the path difference between D2 and D1 is either lambda by 2 or 3 lambda by 2 or 5 lambda by 2 and so on. But here, this is another additional lambda by 2, is it? If it is 0.2 meter, it's going to give additional path difference lambda by 2 for this one. So that can cause total path difference for this D1 and this total path difference. If you consider the path difference for this sound and this one on this ear, it's going to be something like lambda, or earlier if it is lambda by 2 here, it's going to be lambda. If it is 3 lambda by 2 here, it's going to be 2 lambda because of the additional path difference. So here there will be constructive superposition. So the answer should be like that. That's the thing, because if destructive superposition happens here, On the next ear, the right ear is going to get diffracted wave of ANR sound. So there will be additional path difference. If that additional path difference is 0.2 meter due to the size of the head, so at this point, the second ear will have constructive superposition. The idea is if you get path difference here, lambda by 2, here it's going to be lambda by 2 and the additional lambda by 2, it can be lambda here. If you get here path difference 3 lambda by 2, here it's going to be 3 lambda by 2, additional path difference lambda by 2 due to the size of the head. So it's going to be 2 lambda. So there will be constructive superposition on the right here. Okay, so what can be the points to get 6 marks? You can say like this. Now you can say if two waves want to produce constructive superposition, the path difference should be integer multiple of lambda, 2 lambda, 3 lambda, or you can say if they want to have destructive superposition, path difference should be lambda by 2 or multiple of lambda by 2. Then you can say when the path difference is odd multiple of lambda by 2, the waves will overlap antiphase and destructive superposition will occur, so that will cancel the sound. If the path difference is integer multiple of lambda, they will overlap in phase, constructive superposition will occur. So you will get 4 marks for saying this one, right? Then about this one, so then you should say if destructive superposition occurs on the left ear due to additional path difference, there will be some other path difference on the right side, and if the additional path difference is due to the size of the head, which is 0.2 meter, that is lambda by 2, then on the right ear there will be constructive superposition, so the right ear will hear louder sound. Those are the 6 marks points. Okay, question 14 about photoelectric effect. So there are 4 different materials given. You can see the paper. Potassium 3.6 to 10 to the power minus 19 work function. Magnesium 5.89 10 to the power minus 19. Tungsten given, iron also given. So there are 4 different materials and work functions are given in the form of table. So for a part, state what is meant by work function, so that every year they are. So minimum amount of energy required to remove an electron from surface of metal or surface of conductor is called work function. So that is a very common thing. All of you know that. B part, when light with frequency 3.6 to 10 to the power 15 hertz is incident on a metal. So B part, they are giving the frequency of the light. Frequency of the light is given 6.32 times 10 to the power 15 hertz. Is incident on a metal. The name of the metal is not given. The photoelectrons are released with maximum kinetic energy. So maximum kinetic energy also given as 3.60 10 to the power minus 18 joules. Determine which of the 4 metals. So they gave a table, I told already, which metal can give electrons with this as the maximum kinetic energy for this frequency of radiation. So we can use the equation HF equal 5 plus KE max. So H we know that 6.63, Planck constant 10 to the power minus 34. Frequency given 6.32 10 to the power 15 equal to 5. The work function, I am going to find it to compare with the data given in the table, plus KE max given 3.60 10 to the power minus 18. Find the work function. So we will get 5.90 10 to the power minus 19 joules. So if you compare it with the table, magnesium, they are giving it 5.89 10 to the power minus 19 joule for magnesium. So if you almost same, so the metal is magnesium. You should identify the metal, that is magnesium. Okay, so question 14 C part. These are the data given for potassium work function given. That is given on the table on the previous page. Intensity of the radiation falling on the potassium given 38 milliwatts per meter square, and the area on which it's falling is 8.10 10 to the power minus 20 meters square. The question is, ultraviolet radiation is incident on a potassium plate. If the radiation behaved as a wave, but we know that it behaves as a particle, behave as a wave, there would be a time delay before electrons were emitted. Calculate the time taken for potassium atom to absorb enough energy to release an electron. So actually, how much should it absorb? The amount of energy required to remove electron is the work function. So the potassium should absorb this amount of energy if electron wants to be removed from it, right? So the intensity of the radiation falling on the potassium is 38 milliwatts per meter square. So the energy has to be accumulated, and until the total energy becomes this much, the electron will not be removed. That is actually based on wave theory, but we know wave theory is failing there. But if wave theory is correct, how long will it take to remove electrons? But we found that one of the observations, when metals were irradiated with electromagnetic radiations, electrons were released instantaneously without any delay. But wave theory says there will be delay. We are going to calculate what could be the delay if uh, the light or the UV radiation behave as wave in photoelectric effect, right? So the question is, find the time taken. Okay, so we know the energy required to remove is this much. We know the intensity. So we'll find the power of the radiation. You know, I equal P over A if I use it. The answer, intensity equal P over A if I use it. I know the intensity 38 milliwatts. So 10 to the power minus 3. P over area 8.10 10 to the power minus 20. So I will find the power of the radiation falling on it. So that will be 3.08 10 to the power minus 21 watts. So every second the radiation will give this amount of energy. But to remove electron, this amount of energy is required. That's the work function, minimum amount of energy needed. So I can say the work function is the minimum amount of energy required. So that is equal to power into time. Energy equal to power into time. So the required energy is the work function. That is 3.62 10 to the power minus 19 equal to 3.08 into 10 to the power minus 21 into t. So find the time. How long will it take to supply this amount of energy? So you will get almost 118 seconds. So almost 2 minutes delay will occur. But practically they found instantaneously electrons were released because photoelectric effect, in which electromagnetic radiation behaves like particle, not like wave. So it's a good evidence to say that photoelectric effect can be explained only by particle theory of light, not by wave theory of light. Okay, this is the first part of question C. Now, second part of question 14C, first part I discussed. Second part, in practice, electrons are emitted from plate as soon as the ultraviolet radiation is incident on the plate. Explain how this provides evidence for the particle nature of electromagnetic radiation. So, you know, there is no delay. It did not take this amount of time. So, how is it possible? So, 2 marks. You can say photons. You should better say what is photon, or you can say uh, electromagnetic radiation can be described or in terms of photons, where photons are the discrete packet of energy of electromagnetic radiation, which is given by HF. Then you can say when photon interacts with electron, it transfers all its energy and remove the electron instantaneously. You can say those as the two mark. Those are the answers will give you 2 marks. Okay. Okay, question 15. This is about spectra, you know, energy levels of atom. It was that idea was proposed by Bohr. Okay, so there excitation of electron from ground state to zero energy level is called ionization, is it? So the difference between the ground state and zero, that different of that different value, the ground state energy level minus zero gives the ionization energy. So there's an equation for ionization energy, but not in your syllabus. But they are giving that energy. Okay, this is the charge of an electron. K is called actually Coulomb's constant. You will learn that in unit 4. K is Coulomb's constant that has a value 8.85 10 to the power minus 12. That is given in the data sheet. In the question it's given. H is Planck constant. M is mass of the electron. So this is the ionization energy. So nothing, they ask you to find the ionization energy. The equation is given. Only thing you need to substitute the values. All the values are given and they ask you to convert to electron volt. So that's the only thing you have to do. So E is equal to charge of an electron 1.6 10 to the power minus 19 square divided by K is given 8.85 10 to the power minus 12, and H that also said Planck constant, you can find it from the data sheet, 6.63 10 to the power minus 34 whole square. So square the whole thing equal to m mass of an electron, that also given in the data sheet. So that is 9.11 10 to the power minus 31 over 8. So solve it. You will get the answer in joules. You will get it 2.17 10 to the power minus 18 joules. So they ask you to find it in electron volt. So show the conversion 2.17 10 to the power minus 18 divided by 1.6 10 to the power minus 19 electron volt. So you will get 13.5 electron volt. That's the answer for A part. Okay, question number 15B part. They are saying by using Bohr model, that what you learned as spectra, actually spectra is not the topic, actually you learned about, it's an atomic physics, you learned about basic idea of energy levels proposed by Neil Bohr, right? So according to Bohr model, by using Bohr model, we can find the radius of an atom that is given by this equation. So the equation is given in the question paper, not in your syllabus, but it's given there. And also, they are saying, this is the question, so they are giving the radius, right? You can calculate the radius of atom because we know the H Planck constant, K Coulomb's constant, already it's given on the previous page, 8.85 10 to the power minus 12. M is the mass of an electron, charge of an electron. Actually, we can find the radius of the atom by using Bohr model. But the question is, students suggest that for a speed of 1.4 10 to the power 7 meter per second, a neutron would have a wavelength similar to the radius of hydrogen atom. So you should get the idea. Neutron has wavelength. How a particle can have wavelength? We learned that wave-particle duality. Matter has wave called de Broglie wavelength. Is it? So a student says that de Broglie wavelength of neutron when it is traveling at this speed will be same as the radius of the atom, which could be calculated by using equations proposed by Max Planck, proposed by Neil Bohr, right? The question is, determine whether the student's statement is correct. So only thing, you need to find the radius by using this equation, and you should find the de Broglie wavelength for neutron, separately find it and compare the both values. If they are same, then we can say student's statement is correct. If they are different, then statement is incorrect, right? So we'll find the wave. First we'll find the radius for hydrogen. So for hydrogen, so they ask you for atom, no? So hydrogen. So the radius is equal to h squared k over pi m e squared. We'll substitute the values. H is 6.63, 10 to the power minus 34 all things squared. K is 8.85, 10 to the power minus 12 divided by pi times A means mass of an electron 9.11, 10 to the power minus 31 into 1.6 charge of an electron 10 to the power minus 19 squared. So when you find, you will get the radius of hydrogen atom 5.31 10 to the power minus 11 meter. Okay, now we'll find the wavelength of neutron, that is de Broglie wavelength, that is given by lambda equal h over mv. So h is 6.63 10 to the power minus 34. Mass of a neutron is given. We are finding the de Broglie wavelength for neutron at this speed. So 1.67 10 to the power minus 27 into the speed 1.4 into 10 to the power 7. So if you solve it, that value will be 2.84 10 to the power minus 14 meter. Now you can see they are completely different, is it? So Strand's statement is incorrect. That's the final conclusion you should give. It's an incorrect statement. Okay, so question number 16 is slightly different. It's about refraction of ultrasound inside sea, right? So they are giving two different graphs. First graph, how the speed of ultrasound changes with depth. So you can see the values are given. I didn't show that. You can see it on the paper. So when the depth increases, the speed of the ultrasound is decreasing. Maybe the density is changing. That's the reason. Density of the water is changing, right? So that's the reason speed is decreasing. The second graph is about how the depth and distance of the source. So that means what, I'll read the question. So sound produced at depth 900 meter initially travels towards the water surface, right? So what's happening from a depth of 900 meters? So this is the water surface. Maybe this is a point. This point is at a depth of 900 meters, right? So from this depth, they sent an ultrasound. What happened? That ultrasound initially travels towards water surface as the sound approaches depth 700 meters. So when it goes to a point which is 700 meters from the surface, right, what is happening? Sound is traveling from here, but when it reaches 700 meters, it's actually was traveling towards the surface of water, but they thought it will travel towards surface of water. But what happens when it reaches a particular point, that is 700 meters from the surface of water, it started to turn back again. So sound is unable to reach above it. So it's again coming back downwards. It's unable to travel to the higher position, right? They are saying it. The question is, explain why the sound follows the path shown in figure B. So that's the thing, because same diagram I drew it here. So 900 meters from there, they emit ultrasound such that it should reach the surface, but it couldn't reach it. When it reaches a point where 700 meters, it's again going down, right? It's unable to go to even 600 meter or 500 meter depth from the surface. So why is it like that? Okay, you can see that here, compare these two graphs. You can see when the depth increases, so they are sending sound from 900 meters, speed is less. When the depth decreases, that is 900 meter, 800 meter, 700 meter, 600 meter, you can see that on the first graph, graph A, when the depth decreases, speed is increasing. So that means at every height, every position, when the depth changes, the speed is decreasing. So actually what is happening, sound is traveling from low speed position to high speed position. That means it's like acoustically denser medium, like optically denser, optically rare medium we learned for light, where the speed of the light is more, we say optically low denser medium. If the speed is high, we say optically less denser medium, something like that. We can say sound acoustically low denser medium, high denser medium. So it is emitted from 900 meters where the speed is less, means acoustically more denser medium. Then when it approaches a higher position, the speed is increasing. So what happens there, you can see at every point, right? At every point you can see, if I draw normal, the sound is moving away from the normal. The sound is moving away from the normal. We know that whenever a wave travels from one meter, so we can imagine each and every layers of water as different medium, same water, but maybe the density is changing, the temperature of the water is changing, because of that speed is changing. So even though it is water, it has different speed for sound because of different concentration of salt and different temperature. So we should imagine each and every layer at different heights as a different medium. So sound is traveling from a medium where the speed is less to speed is more. So you know that when a wave travels from low speed medium to high speed medium, it will move away from the normal. So you can see it's bending this way. Means if I think about the normal, imagine the layers like this way, every layers like this. If I imagine it's moving away from the normal to the boundary of the layers. Okay, because the speed is continuously, not suddenly changing, speed is continuously increasing. And why it is bending down? Something like total internal reflection. When it reaches a point which is 700 meters from the surface, at that point, the angle of incidence of the ultrasound may be more than critical angle for that boundary. Is it? So that's the reason it's unable to refract into the next layer of water. Rather than refract into the next layer, it is undergoing total internal reflection. The reason is, at that point, the angle of incidence may be more than the critical angle for that position at 700 meters. If you imagine the two different layers of water, so at that position, the speed may be, the angle of incidence may be causing total linear reflection. So if they change the angle of transmission of ultrasound, maybe it can go further, is it? If they, rather than sloping it, if they put it like more vertical, sometimes it might be able to reach the surface. Okay. So the answer for this, why the path is like this, so they are giving 5 marks. So the 5 marks you can write like this. First point, you can say when it is traveling from 900 meters uh, towards 700 meters, the speed of the sound is continuously increasing, not suddenly. The speed of the sound is continuously increasing. So since the speed is continuously increasing, uh, it is moving away from the normal, or the path of the ultrasound is moving away from the normal. You can say that you will get 1 mark. Then you can say, yes, you can say that, no, you will get 2 marks for that. When it moving from 900 meters to 700 meters, speed is increasing. Therefore, it's moving away from the normal. You can say you will get 2 marks. That means why that is happening, you can say the sound or the ultrasound is refracting. That's the reason it's moving away from the normal. Direction is changing. If you say that, you will get the 3rd mark. So what is you should say about speed is increasing, 1 mark. It's moving away from the normal, 2nd mark. So there is refraction, 3rd mark. Then the 4th mark, you can say at point 700 meter depth, the angle of incidence may be greater than the critical angle for the boundary at that point, 4th mark. Therefore, the sound is undergoing total internal reflection. You will get the 5th mark. Okay. Okay, so part B, question number 16, part B. sound that travels in a straight line from the source to point P. So point P and the source, they are almost at the same level, takes longer to arrive than sound that travels along the path shown. So the question is, when it travels like this, it takes shorter time, but if it travels directly, it takes longer time. Why is it? Okay, so that is actually no special explanation. We can say speed equal distance over time, and time is equal to distance over speed. Okay, distance over speed. So actually we can say like this. Now when we consider the direct motion from the source to point P, the distance is shorter, right? But the speed is at 900 meter, so speed also lower. Distance is shorter, speed also lower. But when we consider the path like this, when it goes above 900 meters, that means if then the depth decreases below 900 meters, the speed is increasing. You can say speed is increasing. The distance also increasing. So there's no specific answer. Only thing, the values are giving shorter time. When the sound travels along the curve, distance is larger, speed also larger. When you calculate, it's getting smaller value. But distance is smaller when it travels directly. The speed also smaller, that is giving shorter time. So there is no specific thing. Unless we substitute the values, we can't get any accurate answer. But since they asked, we have to tell that one. Straight travel, distance is short, speed also shorter. Along the curved path, distance is longer, speed is longer. That's all. We can't give any conclusion based on that. So C part of the question 16 suggests two factors that might cause the speed of sound to vary with depth. Okay, I already told that when I started this question. One reason you can say temperature of the water can be different at different depth. Second one, the concentration or density of the water. Okay, so different layers of water will have different density that also can change the speed of the sound. Okay, question 17 about stationary wave. This diagram is given. Normally, we do this practical. Okay, so there first wave, this is an electrical vibrator that is connected to signal generator. Normally, electrical vibrator is connected to signal generator. So, the frequency of oscillation or vibration of the electrical vibrator will be same as frequency of the output of the signal generator, right? So, for example, if the signal generator vibrates at 20 hertz, the AC output, signal generator gives AC output, 20 hertz AC output, the electrical vibrator also vibrate at 20 hertz. Okay, so the wave will travel, and here it's touching the pulley, so it will reflect back. So when these opposite traveling waves overlap, they will form a stationary wave. The superposition will form a stationary wave. So the point where they overlap antiphase, there will be a node and the amplitude will be minimum. If they have exactly the same amplitude, the node will have amplitude equal to 0. If the opposite traveling waves overlap in phase, there will be constructive superposition and it will form antinode. A part, explain how nodes are antinodes are created on a string. So you can say there will be identical oppositely traveling waves and they will overlap. When they overlap in phase, construct the word oppositely traveling waves should be there, identical oppositely traveling waves. When they overlap in phase, due to constructive superposition, antinode will be formed and it will have maximum amplitude. When they overlap antiphase, there will be destructive superposition that will form node. The amplitude will be minimum. Theoretically, you can say it will be equal to 0. Right. Now B part. So we know the tension is provided by the weight of the mass attached here. And they are saying a student is generating fundamental mode. They are not using the word fundamental mode. They are saying always at the ends nodes are formed, and at the center there is antinode. So that means it's a fundamental mode. So the oscillation will be like this, and we know this length is L, and this will be lambda by 2. So the question is, students is repeating this practical by varying the weight and the frequency, but always he is getting the same fundamental mode, right? Only thing, the variable weight and the frequency of the electrical vibrator. So he can vary the frequency of the electrical vibrator oscillation by changing the frequency of the output of the signal generator. The question is, why f squared against w graph, f squared against w graph, w is the weight, is a straight line through the origin. So even if they ask explain, you have to get an equation and show it's a straight line equation. So the A part I can say, sorry, B part I can say this is lambda by 2 is equal to L. From that, lambda is equal to 2L. And we know that for a traveling wave, the speed is given by the transverse wave, V equal square root of T over mu. T is the tension, mu is the mass per unit length, but tension is equal to weight of the attached mass. So I can say W over mu. And for a traveling wave, I can use V equal F lambda for a traveling wave, not for a stationary wave. So there are two identical traveling waves in opposite direction. I am using this equation for one of the traveling waves. So speed is given by square root of W over mu is equal to frequency times, instead of lambda I can substitute 2L. Okay, square both sides, W over mu is equal to 4. If you square the whole thing, 2 square is 4, L squared, F squared. So make the F squared subject. So if I make the F squared subject, F squared is equal to 1 over 4 mu L squared times W. So this is, then you should say here, mu is a constant, L is a constant. So the gradient will be constant. This is in the form of Y. This is in the form of X. So you can say F squared against W will be a straight line through the origin, because mu constant, L constant, so the gradient is a constant, and no Y intercept point. So it will be a Y equal mx, a graph that is straight line through the origin. Okay, C part, they are asking describe a method that can be used to confirm that the frequency values stated on the signal generator is correct. Okay, normally signal generator, there's a display that shows the frequency of output signal. How can you check that value is correct? Okay, only thing, you should connect the signal generator to the cathode ray oscilloscope, and you can get a signal or the wave pattern on the cathode ray oscilloscope screen. So when you think about the cathode ray oscilloscope, the graph or the wave pattern produced on the cathode ray oscilloscope, always y-axis is the voltage and x-axis is the time. That x-axis, the scale can be changed by using time knob. So if you get a graph on the CRO screen, this is the oscilloscope screen. If you get a, there will be like a divisions on the CRO screen, the scales will be there. You can change the values of the scale by using the time knob. X-axis can be changed by using voltage knob. You can change. Say for example, if you get a wave pattern something like this on the CRO screen, something like that, if you get it. So by using the time knob and these divisions, you can find the period of the output of the signal generator. For example, if the time period you keep it at 2 milliseconds, then that means each division is 2 milliseconds, 2 milliseconds, 2 milliseconds, 2 milliseconds. So the time period will be 2, 4, 6, 8. So the time period of the AC signal is 8 milliseconds. So you can find the frequency, you can calculate the frequency, F equal 1 over T, that is 1 over 8 into 10 to the power minus 3 hertz. From this you can calculate, right? So I just took an example and did it, but you can explain. Connect the signal generator to a cathode ray oscilloscope by using the wave pattern on the screen and by using the time knob adjustment. Find the period of the AC output from the signal generator. Then say by using f equal 1 over t, the frequency of the output can be calculated. Okay, so D part of question 17. These data given, so the weight attached given 80 Newton, frequency of the output of the signal generator given. So the length of the string is given. The question is calculate the mass per unit length. So you got an expression or equation in the previous part, f squared equal 1 over 4 mu L squared times W is it. You got an equation, substitute, just substitute 659 squared is equal to 1 over 4 mu times L squared is 0.328 square into W is 80. Find the mu. You will get 4.28 10 to the power minus 4 kilogram per meter. That's all. Okay, question 18. This circuit diagram is given. First part, A part, determine the power dissipated in each of the resistors. So all are identical resistors, 2 ohms, 2 ohms, 2 ohms, like that. So first we can find the current flow. Let the current flow in the circuit I. So I want to find the equivalent resistance of this one. Okay, so these two are in series, so 4 ohms. This is 2 ohms is in parallel with this combination, is it? Because these two are connected next to next, there is no junction, so they are in series. With that combination, this is in parallel. So I want to find the equivalent resistance of this whole thing. So I can say 1 over R1. So I can say this equivalent resistance as R1. 1 over R1 is equal to 1 over 4, because 2 plus 2, 4. 1 over 4 plus 1 over 2. You find R1 is going to be 4 by 3 ohms. You can give it in decimal point. I don't want to give it. I'm just giving it as 4 by 3 ohms. Right. Now, this resistor is in series with R1. So, the total resistance, I can say R0 is equal to 2 ohms plus 4 by 3 ohms. So, now you have to give it in decimal point, or you can keep that also 10 by 3 ohms. That's the total resistance of the circuit, right? Now current flow I should find. I is equal to total applied voltage across the whole system is 10 volt, 10 over total resistance R0, so 10 by 3. That's the reason I didn't solve it. I kept it as a fraction, so you will get 3 amperes. Okay, so that's the current flow, 3 ampere. Now I can find the power in A, so power dissipation in A. So I can say PA equal I squared R. So I squared 3 squared times R is 2. It's going to be 18 watts. Simple. So that's the power dissipation in A. They asked to find the power dissipation in each of these, no? But these two are identical resistors, so they will have the same power dissipation. But I should find the current through B and C, or I can find voltage across B and C. Either way I can find it anyway. So I know this is 18 watts. So voltage across A will be how much? I3 into that resistance. So voltage across resistor A is going to be IR. So that will be current is 3 amperes times resistance of A is 2. So that will be 6 volt. So what's the voltage across the junction? You know that the whole system is in series with this one. So this voltage plus the whole voltage, the total voltage of this combination is equal to 10. So voltage across the junction is going to be 10 minus 6, 4 volt. Right? So the total voltage across D is equal to 4 volt. that is 10 minus 6, that is going to be 4 volt. Same way, voltage across B and C together is equal to 4 volt. So voltage across B and voltage across C will be divided by equally because they are equal resistance. So voltage across B will be half of 4 volt. Voltage across D is 4. That's the voltage across the junction. Total voltage across B and C is also 4, but they are identical resistors connected in series. When components are connected in series, voltage will be divided at the ratio of their resistance. Same resistance, so 4 volt will be divided across B and C equally, 2 volt, 2 volt. So voltage across B, 2 volt. Voltage across C also 2 volt. Okay, so I need to find the power across B. That will be same as power across C. So power across B, I can say V squared over R. Voltage across B is 2, so 2 squared over 2, that's going to be 2 watts. That will be same as power across C also because they are identical resistors. Power across D, how much will be? That also I can say V squared over R. Voltage across D is 4 volt, so 4 squared over 2, that is 8 watts. Okay, very simple question. Okay, so B part of the same question, they're asking, this is A part, what I did. Question 18, A part, I did this. Now B part, they're asking, explain without further calculation what would happen to the power dissipated by resistor A if resistor D were disconnected from the circuit. Okay, now if I remove this circuit D, so that means if I remove this, what will happen? Now you know earlier the equivalent resistance I got 4 by 3, something like 1.33. If I remove it, the total resistance now going to be 4 ohms. Okay, so the overall resistance is going to increase, so current flow will decrease. When the current flow decreases, according to P equal I squared R, the power loss in A will decrease. So your answer should be like this. When D is removed, the total resistance of the circuit will increase and the current flow will decrease. So current through A will decrease. According to P equal I squared R, the power dissipation in A will decrease. That's the answer for B part. C part. If the resistors in the circuit used in A were replaced with filament bulbs. So now they are talking about if the resistors are replaced with filament lamp. Okay, that doesn't matter. They are going to replace all of them by filament lamp. Right. Anyway, but nothing related to this circuit, the question. Okay, so if the resistors are replaced by filament lamp, the resistance of each lamp would be different depending on the potential difference across. You know the current voltage graph for filament lamp, the voltage increases, current will increase, and the graph will turn towards the voltage axis, and we say the current is the resistance is increasing. The question is, explain in terms of particles why the resistance of the filament lamp increases as the potential difference across the filament lamp increase. Same thing like even IGCSE, this question they asked. Okay, you can say like this, when the voltage increases, current will increase, because the reason actually electric field inside the wires increase. But anyway, when the voltage increases, current will increase. When the current increases, drift speed of the electrons will increase. So that will cause more collision among the electrons. So voltage increases, current will increase. When current increases, drift speed of the electrons will increase, and there will be more collisions among the electrons. So when the electrons collide, heat will be produced because electrons are a little bit continuously, they are going to lose kinetic energy, but they will be again gain kinetic energy because of the applied voltage. So due to collision, heat will be formed. So when the voltage increases, current will increase. When the current increases, drift speed will increase. And also, collision among the electrons will increase. When the collision among the electrons increases, heat will be developed. Okay, heat will be produced. When the heat increases, the atomic plates, the Bravais lattice, will start to vibrate. So, what happens? That will cause rate of flow of increase of current to decrease. So rate of increase of current will decrease. That means resistance will decrease. Okay, so in overall I can say when the voltage increases, current will increase. When current increases, drift speed of the electrons instantaneous. Okay, the drift speed of the electrons will increase. When the drift speed increases, collision among the electrons will increase. That will cause increase in temperature. When the temperature, the heat increases, atomic planes will vibrate, and in overall, what happens? Rate of increase of current will decrease. That means resistance will increase. Okay, that means resistance will increase. Okay, so those are the 4 marks we are expecting. Okay, so that's all this May 2020 IAL Unit 2 paper. Okay, right.